Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is magnitude comparator from Unit 4 Interconnect Memory Architecture and Arithmetic Circuits. On completion, the students will be able to understand the logic of a magnitude comparator and also be able to construct a cascading comparator using 4-bit magnitude comparators. What is a magnitude comparator? A magnitude digital comparator is a combinational circuit that compares two digital or binary numbers in order to find out whether one binary number is equal to or lesser than or greater than the other one. We logically design a circuit for which we will have two inputs, one taken as A and other for B, and we have three output terminals, one denoting A greater than B condition, one for A equal to B condition and the other one for A less than B condition. Magnitude comparator is a type of combinational circuit basically compares two binary numbers and determine their relative magnitude, and it gives the output whether one number is greater than or equal to or lesser than the other. These comparators are used in digital systems such as for sorting networks, decision making circuits to handle numerical comparisons perfectly without creating any error. This is a diagrammatic representation of a n-bit comparator with two inputs A and B and outputs A greater than B, A equal to B as well as A less than B. 2-bit magnitude comparator. A comparator used to compare two binary numbers, each of 2 bits is called as a 2-bit magnitude comparator. It consists of 4 inputs and 3 outputs to generate less than equal to as well as greater than outputs between the two binary inputs. So the diagram represents a 2-bit magnitude comparator with inputs A and B, A0 A1 as well as B taken as B0 B1, and we have inverter, AND gate, XNOR gate and OR gate to obtain the outputs A greater than B, A equal to B as well as A lesser than B. Similarly, we can design a 4-bit magnitude comparator. A comparator used to compare two binary numbers each having 4 bits is called a 4-bit magnitude comparator, and it consists of 8 inputs each for two 4-bit numbers and 3 outputs to generate the lesser than, equal to as well as greater than outputs between the two binary numbers. So in a 4-bit comparator, the condition for A greater than B can be possible in the following 4 cases. If A3 equal to 0, 1 and B3 equal to 0, if A3 equal to B3 and A2 equal to 1 and B2 equal to 0, if A3 equal to B3, A2 equal to B2 and A1 is equal to 1, B1 is equal to 0, and if A3 equal to B3, A2 equal to B2, A1 equal to B1 and A0 equal to 1, B0 equal to 0. Similarly, for the condition A less than B is possible in the following 4 cases. If A3 equal to 0 and B3 equal to 1, if A3 equal to B3 and A2 equal to 0 and B2 equal to 1, if A3 equal to B3, A2 equal to B2 and A1 equal to 0 and B1 equal to 1, if A3 equal to B3, A2 equal to B2, A1 equal to B1 and A0 equal to 0, B0 equal to 1. The condition of A equal to B is possible only when all the individual bits of one number exactly coincide with the corresponding bits of the other number. That is A0 equal to B0, A1 equal to B1, A2 equal to B2 and A3 equal to B3. The diagram represents a 4-bit magnitude comparator. Cascading comparator. A comparator performing the comparison operation to more than 4 bits can be obtained by cascading 2 or more 4-bit comparators. So this forms a cascading comparator. When two comparators are to be cascaded, the outputs of the lower order comparator are connected to the corresponding inputs of the higher order comparator. So the spin diagram represents a cascading comparator. Quiz questions on magnitude comparator. Explain a 4-bit magnitude comparator with necessary diagram. Construct a cascading comparator using 2 or more 4-bit comparators. Thank you.